Hello, in this video we are going to complete the prep task for our recursive backtracking algorithm example that we'll be completing a little later. And what we're going to do is generate an array, a two-dimensional array with some randomized elements. We're going to use this as an opportunity to kind of clarify some ideas surrounding two-dimensional arrays as well as multi-dimensional arrays in general. So I've asked everyone to use the exact same parameter names and method names because it makes it a little easier when we're trying to talk about things a little later. So we're going to make a method called genArray. It's going to take an integer called rows, an integer called columns, and an array of characters called poplist. It's going to return a two-dimensional array of characters, and it's going to create a randomized 2D array that contains the elements from poplist randomly placed. So for example, if I had in some method somewhere, for example a main method, I had an array of characters called C, and that contained RGB, and then I called the method genArray with for C. That means that it's going to generate an array with 4 rows, 4 columns, randomized with the characters R, G, and B. And here's a possible example of what might be returned. Again, it's randomized, so we don't know for sure what will exactly be returned. And we're going to do an add-on in this prep task is we're going to make a method to print out two-dimensional arrays because it's going to be useful for a lot of things. And with that in mind, let's dive in. So right-click, new, class, call this prep task 1, and we're going to include a main method in this. There we go. And let's just get rid of that. So the first thing I'm going to do is I'm going to set up my method header, public static char. Because I'm returning a two-dimensional array, I'm going to notate it with just 2 sets of brackets. genArray, int rows, int cols, and char. I think I called it poplist. Let's just go back and really quickly check to make sure. Yep, poplist. Perfect. And that should actually be a one-dimensional array. So you'll notice when we're working with multi-dimensional arrays, it's very similar to working with one-dimensional arrays. We just add an additional square bracket. If I wanted to make a 3-dimensional array, I just add another one. And a lot of the concept around loops that we're going to talk about with this is just naturally extends. We just need one more loop for every dimension. And you'll see what I'm talking about shortly. Now we have an error right now because we haven't returned anything, so I'm just going to return null at the bottom just as a catch-all return. And we're going to come up into our main method, and let's make our array of characters called C, and we're going to populate with R, G, B. Oops. Now, just be aware, a couple students asked me about this. They completed this task and printed out their array, and all they got were a bunch of question marks, and that's because they populated the arrays with integer values like this. And if you do that, the problem with this is that this isn't the character one, it's whatever character is associated with the integer value one using the ASCII mapping table. So you'll get a question mark because the computer doesn't know what actual character is represented, or it just can't represent it. So make sure you have single quotes around that. And we're going to go back to R, G, and B. There we go. Okay, so let's make a two-dimensional char array called grid. And I'm just going to invoke genArray. And I'm going to say for C. And there we go. Okay, so how am I going to do this? Well, what I'm going to do is I'm essentially going to work across each row and down. So if we take a look back at our OneNote, what I'm going to do is if we number this, and let's zoom in a little bit here, that might be a good idea. Okay, let's zoom in a little bit. This over here, let's see if I can do this. Actually, let's do this. We're going to insert some rows above, and we're going to insert some columns to the left. Somewhere in here. Insert left. There we go. Okay. So let's come down a bit. Let's make this a little larger. There we go. So this would be our rows. So this is row 0, this is row 1, this is row 2, this is row 3, this is column 0, this is column 1, this is column 2, this is column 3. So this position is 0, 0. This position is 0, 1. This position is 0, 2. This position is 0, 3. This position is 1, 0, because it's the first row and the 0th column. So if we want to access this element, we have to pass both a row and a column. Now I'm going to pause the video and just fill in the rest of this table, and then we'll talk a little more. So I've filled in the rest of the table now, and I've actually taken a moment and made the column number in red. So the way this is going to work is our first loop is going to control the rows, and the second loop is going to control the columns. So we're going to start off at row 0 and then go 0, 1, 2, 3, 1, 0, 1, 2, 3, 2, 0, 1, 2, 3, 3, 0, 1, 2, 3. And let's start by actually just setting that up. And we're not going to set it up in terms of the array for a second. So if I go for int r equals 0, r is less than 4 r plus plus, for int c equals 0, c is less than 4, I made the classic mistake, go, c plus plus. This is my nested loop structure, which is essential to two-dimensional arrays. Now, it's obviously not ideal because it's always going to 4, but we want it to go to the actual size of the array. So I'm going to have it go to rows, and I'm going to have it go to calls. So what I can do now is I'm going to start off by creating my array. So char a equals new char, and this is going to have rows, calls. There we go. And what I really like to do is I always like to use R for the rows, C for the columns, and just be consistent in that use, because that's actually really helpful for later on in mathematics when you talk about matrices, because it's always rows and columns. So what I need to do here is I need to generate a random number from 0 to poplist.length, and actually 0 is less than or equal to n, which is less than. And then once I've generated that number, assign the value to a from poplist at n. So we're just going to simply say int num equals int math.random, and I'm going to multiply this by poplist.length. There we go. And then all I have to do is I just have to say a at r c is equal to poplist at n num. And so what this is going to do is this first loop is going to go through the number of rows. And so it's going to go 0, and then I'm going to go through the columns, and I'm going to pick a random, generate a random integer, which is within the index range for poplist, and then pull the value from poplist and put it in at RC. And we're not going to return null, we're going to return A. So if I run this now, nothing happens because I haven't printed out the array. So let's write a quick method that's going to print the two-dimensional array. So I'm going to make a method called print2darray, and I'm going to pass it an array. So if I come down here, let's actually do it right here. I'm going to say public static void print2darray grid, open a brace, actually not grid, sorry, char grid. And I just have to run that nested loop structure. So I'm going to say for int r equals 0, r is less than grid.length, and grid.length will give you the value as of the number of rows in a row. And then I'm going to say r plus plus. For int c equals 0, c is less than, and this is the tricky part, because if grid.length gives you, and we look down here, the first parameter in terms of the size, how do I grab the second parameter? Well, the way I do it is I take the grid and I specify a row. So I'm going to say grid at r dot length. And so grid at r dot length will give the second parameter in terms of the size of that array. C++. And then inside here I'm going to go system.out.print grid at r c and I'm going to put a space in between them, space between each element, and then I'm going to come down here, and basically I want each element in a row to print out on the same line. And once I'm done a row, I want to print out just a fresh line. And if I've done this correctly, there's my two-dimensional array, 4 by 4 with randomized RGBs. And notice every time I get a slightly different one. And if I wanted to, I could make this 40 by 40, and there's a 40 by 40 array. And so what we're going to use this for is we're going to use this to look at how to clear out certain values using a recursive backtracking algorithm in our future class. I hope this helped, and as always, if you have any questions, don't hesitate to ask.